with trigonometry and with the angles in trigonometry, you have equivalence. Here's what I mean by that. Let's take the sine graph. Let me draw that better. Something like this, right? 1 minus 1. 0, 90, 180, 270, 360. Blah, blah, blah. If you plugged in sine 0, you get 0. If you plugged in sine 180, you still get 0. If you plugged in sine 360, guess what? You still get 0. If you plugged in sine 90, you get 1. And if you plugged in sine and then whatever this value is, what would that be? 360 plus 90. 450, I think. Let me check. Yeah, 450. Sorry, my mental maths should be a lot better. That would still give you 1. Those are equivalent. Sine 90 and sine 450 are equivalent angles. You get the same thing with cos, you get the same thing with tan. So let's say you had a value here. Why did that move? There we go. In red, you have a value there. If I drew a dotted line, this value, this value, this value, that value, they all have the same y coordinate. They all have the same value of y at different angles. So those angles are equivalent. So if you want to find, or how shall I put this? In trigonometry, when you're solving, you're not going to get just one value. You're going to get multiple. The way you work out the multiple is by working out the equivalence. Now, your school may teach you this graph method, where you see how I've drawn a dotted line and I've tried to identify the equivalent angles. I wouldn't suggest doing that, because in a sketch, it's very hard to determine where, let's say, 0.23 is on the y-axis. It's almost impossible. There's no scale when you have a sketched diagram. So instead, we use the cast diagram. Here's how the cast diagram works. You draw a big plus sign. This big plus sign is split into 4 quadrants. C, A, S, T. In that arrangement, that's why it's called cast. Now, the A stands for all, S stands for sine, T is tan, C is cos. I'm going to explain why that is. But the points, so starting from here, that value is 0 and 360 degrees. This point is 90 degrees. This point is 180 degrees. This point is 270 degrees. Okay, suppose I have the following value for theta. Let's say I have sine theta equals a half. That's my equation. My value for theta, therefore, would be sine minus 1 of a half, which is 30 degrees. Okay? Here's what I'm going to do. In my cast diagram, according to the values that I have at each point, 0, 90, 180, 270, I'm going to draw a line representing 30 degrees. Doesn't have to be exact, can be as rough as you want, but has to kind of make sense. That's 30 degrees. Now, depending on what type of function I have, what type of trig I have, sine, cos, or tan, that will determine how that black line reflects. If I have a sine function, my black line, my line that I drew for 30 degrees, will reflect on the horizontal axis, where this is also 30 degrees. So this is for the sine function. If I have the tan function, it's just gonna go straight through, like this. This is for tan theta, where this is 30 degrees. If I have a cos function, it's gonna reflect in the vertical axis, where this is also 30 degrees. So, let's look at this one in particular. CAST 0, 360, 90, 180, 270. I draw 30 degrees. I have a sine function, which means it's going to reflect this way, and this is 30 degrees. Okay, here is how you find the equivalent angle to 30 degrees. You're going to start from 0, and you're going to make your way anti-clockwise until you hit a line. Whatever angle that makes is your solution. So let's start from 0 here, and let's make our way anti-clockwise until we hit a line there. This arrow is 30 degrees. Okay, let's start again. Let's do another one. We're going to keep going. We're going to go past until we hit another one there. That big yellow arrow, what angle does that make? 150. Because you do 180 minus 30. Okay, so theta equals 30 and 150. You can keep going. You can go round as many times as you want. But it's mostly going to be anti-clockwise. How you know how many times to go around comes down to the limits. Let's say your limit is 0 to 360 degrees. If you were to try a third time, so if you went all the way around and then you did that, you've gone past 360. Technically, yes, it is an equivalent angle. However, you've gone past your limit, so it doesn't work. Okay? Right. Let's try another one. Let's do cos a half. So cos theta equals a half. If cos theta equals a half, theta is going to be cos minus 1 of a half, which gives us 60 degrees. Okay, we draw our cast diagram again. CAST. We label our points 0, 360, 90, 180, 270. We draw our line for theta that we just calculated, 60 degrees. And now we do our reflection. We've got a cos function that will reflect on the vertical axis, like this, where this is also 60 degrees. Now, we start from 0, we make our way anti-clockwise, 60 degrees, and then we do it again. Keep going, keep going. Let me redraw that. There. What is that big yellow arrow? What's that angle worth? 300. 360 minus 60. 300. So, your values for theta are 60 and 300 degrees, which means cos 60 is a half, cos 300 therefore will also be a half. I hope that made sense. That's how the cast diagram works, and that is how you're going to use it.